So today we are going to talk about part 5 of Java OCA exam 1Z0-808 loop constructs. Part 5.2 is enhanced for loop, break and continue and label statement. So first slide is enhanced for loop, what it does and what it cannot do. So enhanced for loop, also known as for loop for each loop, provides a simple and readable way to iterate over an array or collection when you only need to access the elements. So if you see the screen, you have an int array 10, 20, 30, 40, 50, and how do you read those elements? So if you do for int element add, then you will system.out.println, okay? So that will print 10, 20, 30, 40, 50. The syntax is very straightforward. For int element colon array name, during each iteration the variable element receives the next value from the array. An important limitation to understand is that the loop variable holds a copy of the array value, not the reference to the actual position in the array. Therefore, if you write something like element is equal to element into 2, you are only modifying the local loop variable, not the value stored in the array. The original array, it will remain unchanged. If you need to modify the elements of an array, you must use a traditional for loop with an index and update the elements using array name within I, right? I the index. The enhanced for loop cannot modify any array elements directly. In exam questions, you may see an enhanced for loop that appears to change array values. However, the correct answer is usually that the element and the array remains unchanged because the loop variable only works with a copy of each element, okay? So you have to remember that. So the break statement immediately terminates the innermost loop in which it appears. When break is executed, the loop stops running and control moves to the first statement after the loop. Say in the for loop where int n colon add, and if n equal to 3 break, system.out.print, then n, then what is the output, right? So output is 1 and 2. What happens is that here, so you are iterating over the array, right? So it prints 1, 2, but in that case, in the third value of the array is 3. So that reaches the condition 3 equals 2 equals 3, right? So then there will be a break. So it will come out of the for loop, okay? And then there is a break in nested loops, only exists the inner loop, right? So in case of nested loops, the break statement affects only the loop it is directly inside in. The outer loop continues executing normally. The distinction is very important because a single break cannot admit multiple levels of nested loops unless level breaks are used, okay? So you have to understand this very well. So say we have one loop on the top, and for int I is equal to I less than equal to 3 I plus plus, and then for int j is equal to 1 j equal to 3, then j n plus plus, and then condition is if j equals to, then it breaks, right? 1 1 2 1 and 3 1, because as soon as j reaches 2, right, it will come out of the loop, right? So the above loop will be there, but the inner loop after once j becomes 2, it will break it, okay? So you will see 1 1 2 1 and 3 1. And next condition is there is also an important compile time rule to remember. And next one is there is also an important compile time rule to remember. Any code written after a break statement within the same block is considered unreachable code, since the compiler knows that the break will always execute before the code can run. It produces a compile time error. Okay. So in the last example, you see for int n and then array name, and then you see a break statement. Now, once the break statement is encountered, right, there is the next statement. If we write something like system.out.println n, it becomes unreachable, right? Because it will never reach. So break, once you encounter break, it will come out, right? So then compiler will flag it as an error. So it's an unreachable statement. We have to remember this, and this will come in the exam many a times. Okay, so we have to remember this. Continue. Skip to the next iteration. The continue statement skips the remaining code in the current iteration and immediately moves to the next iteration of the loop. Unlike break, the loop itself does not terminate. It simply continues with the next cycle. In a for loop, when the continue is executed, control jumps to the update expression, and then the loop condition is checked again. So if you see the first example, when n equals 3, continue, right? So it will not print that system.out.println where n is equal to 3. So it will print 1, 2, then it will skip, then again move back to the loop, and it will print 4 and 5. So 3 is skipped, loop will continue. So in a while loop, continue jumps directly back to the condition check, skipping any remaining statements in the loop body. So similar to for, what we see is that when I, in the second example, if you see I equals 3, continue, right? So what will happen is that when, so it will print when I is equal to 1, 2, it will print well, right? It will print, there will be output 1 and 2, but 3 it will skip, right? Again it comes back to the loop, and then 4 and 5 will get printed. So because the condition is I equals true, it will continue, so it will not print 3 here, so it will become 1, 2, 4, 5. Okay, so in while loop what happens is that the continue, once we encounter continue, it will jump back to the condition check. Condition check is what? In this case, I less than 5. Now, this behavior can create a subtle trap in the loops if the counter increment is placed after the continue statement and the continue executes before the increment is reached. The counter will never increase. As a result, the loop condition will never become false, leading to an infinite loop even though the code will compile without errors. So a safe practice when using continue in a while loop is to update the counter before the continue statement, or ensure that the continue cannot execute before the counter update. So if you see the last example, right, j less than 5, if j is equal to equals 3, continue, right, and then j plus plus. That means when it reaches 3, it will again come back to the condition j less than 5, so 3 less than 5, again it will keep continue, again go back to the condition j less than 5, 3 less than 5, keep doing like that. So it will become an infinite loop because j plus plus is after the continue statement. So you have to remember that. So next slide is label break escaping nested loops. Okay. So labels allow you to exit an outer loop directly from inside a nested loop. A label is simply a name followed by a colon, placed immediately before a loop statement. When you use a label statement such as break outer, Java does not just exit the inner loop. Instead, it will exit the loop associated with the label. So if you see the example here, the outer loop runs I from 1 to 3, and the inner loop runs j from 1 to 3. When I becomes 2 and j becomes 2, the statement break outer is executed. Before that point, the program has printed 1, 1, then through 1, 2, 3. Before that point, the program has printed 1, 1, then 1, 2, then 1, 3 during the first iteration, and then in the next iteration 2, 1, right? So once the break outer executes, right, Java exits the entire outer loop, so the loop does not continue with I equal to 3. This appears very frequently in OCA exam, so you have to be careful. So you may be shown nested loops with label and asked to determine the exact output that is produced. Label continue resume at the outer loop, right? So label continue works similar to a label break, but the behavior is slightly different. Instead of exiting the outer loop completely, it skips to the next iteration of the labeled outer loop. When continue outer is executed, Java stops the current inner loop immediately and jumps to the update and condition check at the outer loop. This means the rest of the inner loop is abandoned and the execution continues with the next cycle of the outer loop. So if you see the example here, so whenever j reaches 2, the statement continue outer runs. As a result, the inner loop stops at that point. So only the case where j equals 1 is printed for each value of I. Okay. And the output therefore becomes 1, 1, 2, 1, and 3, 1. The distinction, this key distinction to remember here is this. So break outer exits the outer loop completely, while continue outer skips outer, while continue outer will skip the rest of the current iteration and moves to the next iteration of the outer loop. Okay. Let's come to the practice question. So we have a class here, and here there is an outer loop. So here we have two loops, outer loop from 0 to I less than 3, and then for int is equal to 0 less than 3, and then continue outer and system.out.print, right? So what will be printed? So what is the output? Output answer is B, 0, 0, 1, 0, 2, 0. So when j equals 1, continue outer will fire, the inner loop is abandoned and the outer loop moves to the next I. Only j equals 0 ever executes the print. So for each I 0, 1, 2, only I plus 0 will print. Okay.